Hello, this is Ro. Today I'm going to talk about one of the evaluation matrix. This evaluation matrix is widely used in a situation where we predict the binary categorical variable, such as true false, as dependent variable, also known as target. We can think of some examples where the targets that we wanted to predict are binary categorical variable. For example, in the case of COVID-19, if you go to take a test for COVID-19, the result that you get is either positive or negative. And in the card transaction data, if you wanted to build a model that actually tests whether the transaction is fraud or not, the result output will be either fraud or genuine transaction. Also, there's one more example that in a credit scoring market, the modelers wanted to analyze whether the people register for the loan. We wanted to find whether the loaners is going to default or not default. Also, it's a binary, and also if in terms of weather forecast, you might want to know the temperature will go up or down. So these are the examples of binary categorical variable as dependent variable. And most of the cases, the output result is the list of those predicted labels. And those labels are determined by the probability from the model and the predetermined threshold. We're not going to talk about those, how we're going to decide the labels and the model itself, but rather here today we're going to talk about how we can evaluate those predicted labels and the true labels. So I made a very simple and artificial data where the y, I sample from the binomial distribution with a sample size of 25. And here, this is the list of the output that I got, where there are 6 positive results and all the rest of them are negative. And just to make the analysis reasonable, I changed the 3rd, 5th, and 25th of the elements, made it opposite so that we can actually evaluate whether the model predict well or not. Well or not. So I made up 2 data sets. The first one is the true label of y, and the second data set is the y hat, which is the result output from the model that we used. Although we don't have a model and we haven't talked about model yet, but just think about this y hat as the output result from the model that we're interested in. And most of the cases in analysis, we wanted to know, like, what's the error rate? How well did the model predict? The first matrix that you can think of is how many errors are there out of the total. So in this case, I artificially changed the results from the true label and make it opposite for 3 of the labels. So basically there are 3 errors and the total sample size 25. So there are 3 errors out of 25. So the error rate is 12%, which is basically the mean misclassification error. But in the situation of binary categorical variable, we can go more deeply to think about among those labels, how often it may error, or among those y hats result outputs, how often the model made an error. So to answer those questions, typically the researchers use 4 different types of values, and those are true positive, true negative, and false positive and false negative. So to see the definition of each, true positive is the outcome where the model correctly predicts the positive class, and true negative is the outcome where the model correctly predicts the negative class. So to think about example, in the case of COVID-19, you actually got a COVID-19 and you go for the test and you got a positive result, then it's true positive. And reversely, if you didn't get a COVID-19 and you go for the test and the test shows it's negative, then it's a true negative. And it's easy. However, in other case, for example, you got a COVID-19 and you had a very high fever and you have a very symptoms, but then you went for the test and the test shows that you're not a COVID-19. But the test is not always 100% correct. But anyway, in that case, it's a false negative. For the false positive, you actually didn't have any symptom, and you are actually not a you didn't get a COVID-19, but in the end you went for the test, and the test result shows that you actually tested for positive. In that case, it's a false positive. And to actually, for the data that we have, two data sets, Y and Y hat, we wanted to count how many true positive and false positive and true negative and false negatives are, to get a sense of where the model actually correct, how the model performs well in different situations. First of all, true positive, we only count when the true label Y and the Y hat, the model output, equals as 1. We count up the true positive. And for true negative, we only count when the Y, the true label, and Y hat, the model output, equals to 0 at the same time. And for false positive, because the test shows is a positive, which is a Y hat is a positive as a 1, and also at the same time, the true label is not same as the positive test result. So in that case, we count up the false positive and false negative for the vice versa. And that's how we count up the true positive, true negative, and false negative. And then we also interested in how many positive are there, how many negative are there in the true labels, and those numbers in the Y hat as well. And if you read a paper or just read any article, statistical article that deals with the prediction of the binary categorical variable, they always talk about true positive rate, true negative rate, false negative rate, false positive rate. And the way it is calculated is using the value of true positive, true negative, and those, we just divide it by the number of true, the number of positive, the true label in the positive in the true label and negative in the true label, each from the true positive and true negative. And also the false negative and false positive rate is calculated by dividing the positive value from the true label by the false negative, and false positive divided by the negative value in the true label. And this is actually what we calculate in manually, but in the Python, they have scikit-learn package. They provide a function like ConfusionMatrix and ConfusionMatrix display. So by using this, we can have a nicely graphed, visualized ConfusionMatrix. For the first part, first graph, it shows that there are 5 true positives and 17 true negatives, and 2 for the false positive. Yeah, false positive, and this is for false negative. And if we normalize it, what do we mean by normalize this is by we sum up the number in the column. For example, if we sum up the row wise, 17 plus 2 is 19, and if we divide it by 17 by 19, we get the number 17 by 19. We get the number of 0.89. So we sum up the true label of negative, and we divide it on the top of the graph. It has these numbers. And also for the second row, if we sum up the 1 and 5, it's a 6 total. And 1 divided by 6 is 1.666, and we round up to get a 0.17. And for the positive, like true positive, there it is 5, and divided by 6, we got 0.83. So I just go through from like how to evaluate the true label and the predicted output label. And this is what people normally do in the situation where we predict the binary categorical variable. And that's all for today. And if there's some other topics that I'm going to explain later, I'll definitely upload videos later on. Okay, thank you for watching. If you have any question, please ask me through email or text.